Hello, and welcome to my presentation titled Investigating the Impact of Delta-9 Tetrahydrocannabinol and Cannabidiol on Mammary Gland Remodeling and Function During Pregnancy. My name is Chitman, and I'm a PhD candidate exploring this fascinating area of research under the supervision of Dr. Chitmandeep Josan. In this study, we're exploring the impact of maternal cannabis use during pregnancy on mammary gland development and function. 4.2% of women report using cannabis during pregnancy in Hamilton, and this number rises to 30% in vulnerable populations across North America. Cannabis use during pregnancy is associated with preterm labor, low birth weight, admission to the neonatal intensive care unit, and is also linked with increased risk of stillbirth. Maternal cannabis use is also linked with lower rates of breastfeeding initiation and shorter duration of breastfeeding. Breastfeeding is recommended for the first 6 months of an infant's life as it provides essential nutrition and immunity to the infant. The mammary gland undergoes a critical phase of remodeling during pregnancy, which prepares the gland for lactation. Cannabis lowers prolactin and oxytocin levels, both hormones that are essential in remodeling of the gland. And cannabis impacts breast milk volume as well as composition in animals. The remodeling process involves alveolar differentiation of mammary epithelial cells. However, the effects of cannabis or its components, including THC or CBD, on alveolar differentiation have not been explored yet. In this study, we've been looking at the effect of cannabinoids, THC and CBD, on alveolar differentiation of mammary epithelial cells using the HC11 cell line. The HC11 cells are seeded and differentiated over 4 days. At day 0 or at differentiation, the cells are treated with various induction factors along with either methanol, THC, or CBD. At day 4, cells are harvested for various assays including MTS and LDH assay to assess cell viability, RT-qPCR to assess changes in gene expression, Western blotting to assess changes in protein expression, and ELISA to assess changes in protein secretion. We will be looking at markers involved in synthesis and secretion of milk proteins and fat. Beta-casein and whey-acidic protein are two major milk proteins synthesized and secreted by mammary epithelial cells. Thus far, our results show that CBD lowers beta-casein and whey-acidic gene expression, as well as beta-casein and whey-acidic protein expression. However, THC only lowers whey-acidic protein expression. Next, we hope to determine changes in the secretory profile of these markers. Along with milk proteins, differentiated mammary epithelial cells synthesize and secrete fat. Therefore, we looked at the effect of THC and CBD on fat accumulation in HC11 cells using an oil redo assay. We found that both THC and CBD lowered the levels of fat accumulation in HC11 cells at 10 and 20 micromolars. We also looked at gene expression of associated markers and found that THC and CBD at 10 micromolars decreased gene expression of fatty acid synthase as well as fatty acid binding protein 4, markers that are involved in fat synthesis and fat transport, respectively. So altogether, our results show that THC and CBD impact fat synthesis and milk protein production. Next, we will investigate whether the effect of THC and CBD on HC11 cell differentiation are mediated through CB1 and CB2 receptors. As with every in vitro study, our cell culture model may not be fully representative of the functional organ. Therefore, we're planning to conduct an animal study with mice later this year to answer this question in excessive detail. Finally, cell or animal studies do not fully demonstrate the impact of a drug as seen in humans. Therefore, we're currently running a human study in which we assess changes in breast milk composition of milk collected from cannabis users as well as non-users. Impairment of the alveolar differentiation by cannabis or its components could result in improper mammary gland development, which could impact breast milk production and/or composition. Furthermore, exposure to cannabis through breast milk and altered breast milk composition due to maternal use may impact infant health. Results from this study will allow us to provide evidence-based advice to women using cannabis during pregnancy and/or breastfeeding. That's all for me today, and thank you for listening.